Okay. So as I said, we will start with machine learning today, and we will be starting with the projects. We'll be starting to build projects and then push it on GitHub. So let's try and make the best out of this. All right. So before we go to machine learning, most people use the is quite everywhere, and or one is a subset of the other. Guys, you let me know already. Oh my. Okay. Is it better now? Can you hear me now? Okay, so as I said, we will try to find a difference between artificial intelligence and then machine learning. Okay, so the start class, some of the concepts which are left, we will be learning it side by side. Okay, so as I said yesterday, learning it alone becomes quite boring and exhaustive, right? So we will be learning it side by side so that we get to know the significance of it and the relevance of it, right? So as we encounter it, then we will just take a detour and then explain that particular part. Okay. So let's try and then see the difference between artificial intelligence and then machine learning. Okay. So artificial intelligence, as I said, is the big umbrella here. Okay. Let me try and bring my pen. Option done. Yeah. So artificial intelligence is actually the big umbrella here, and then under that we have machine learning. We have a lot of concepts there. We have expert systems. We have NLP. We have speech recognition, the likes of robotics, and then vision, right? Computer vision and things like that. So machine learning is just one part of artificial intelligence. Okay, so let's get to that one straight before we move on. Machine learning is just one part of it. It's just one subset of the big umbrella artificial intelligence, all right? And inside machine learning, we also have subsets, right? Which the dominant one being deep learning. Okay, so if time permits us, we will also go into deep learning, right? So for now, we will start with machine learning, and then if time permits us, we will dive into deep learning also. Okay, so machine learning is a subset of artificial intelligence. Okay. All right, so we will be concerning ourselves mainly on machine learning. All right, so let's try and then get to understand what machine learning is and the various concepts. So this is how we actually going to do this. We will first, before we go to the Jupyter notebook and see how these concepts are being used and how we will get hands-on experience or familiarity with the concept, right? Let's try initially to get understanding of some of the concept so that when we get into the Jupyter notebook, we will not be new to the concept, right? We will be familiar with some of the concepts. So we will be starting with introducing some of the concepts, and then later on we will move on to the Jupyter notebook to see how these things are being implemented. Okay. So as I showed you earlier on, artificial intelligence is the big umbrella here. Inside that, we all have machine learning, and then machine learning, we have deep learning in there, right? You can also see it from the circle over here, all right? Where the big circle being AI, and then ML here, and then deep learning being the smaller one here, which is under machine learning, okay? Okay, so we will start with machine learning and then get to understand what machine learning is. All right, so as the name goes, it's a machine trying to learn and then help us make decision. All right, but how they learn and how they help us to make decision is why we are taking this course. Okay, so machine learning is nothing but just learning from some given data. All right, you give the machine some data, and then the machine will figure it out and then gain experience, just like we human beings learn, and then we become experienced in whatever we learn, and then later we can actually do whatever we have learned. All right, it's the same thing the machine will be doing. We just feed it with some kind of data points. All right, then it will learn from these data points, and then when new data points are coming in, right? Let me change this. Yeah. When new data points are coming in, then it will figure out what to do with these data points, right? Based on the experience that it has gained from these ones that it has learned. If new ones are coming in, it will rather know what to do with this data, right? Based on what it has learned from this. So basically, that's what machine learning is all about. We have some given data. We want to gain insight from future data. All right, so we feed a machine with the data that we have at hand, so that when we encounter new data, we can be able to make decision out of the new data. Okay, so basically that is what machine learning is all about. Okay, just give me 1 minute. Let me mute this before you give me feedback. Okay, so this is a classical definition that you can find online. Um, we're actually going to just break it down so that you get to know what it means, right? So what's this one is actually trying, what this definition, this long definition is actually trying to say here is that we build algorithms, right? We build machine learning algorithms or models, all right? And these are backed by some mathematical concepts that we know, all right? Some mathematical concept that we know, and then as we go to the Jupyter notebook, you will get to know what I mean by this, right? We base on these concepts, and then we build some models. All right. Now, what we want to actually do is to actually find some patterns, right? We want to see some patterns in the data that we will be feeding the machine. Okay, so that we can actually base on those patterns that we find in that data point, and then make future decisions. Okay. And what we actually want to avoid is to actually program the computer explicitly, all right? Because if you actually want to program the computer to perform these tasks, then it's going to be very, very difficult, all right? And that's what we don't want to do. And that's what machine learning helps us to avoid. And the main reason why it is becoming quite dominant in the system, because with the traditional programming, like the likes of Java and those stuff, right? These machine learning algorithm is helping us to make things very, very easier without spending that kind of time and stressing ourselves to do all those kind of work. All right. Now let's take this case. Let's take this case. This is a classical definition that is given by Casey. Casey works at Google, right? It's kind of a definition that she gave, and I find it to be very intuitive. Let's say we have a bunch of cards, right? We have some data on cards, right? Then in future we want to say that, okay, if there are some group of animals, can we identify a cat among them? All right. If it is human being, naturally, as we grow up, we get to know it, right? We get to know that this is called cat, this is called dog, this is called bird, whatever. pets that you have, right? Naturally, we get to know them based on the environment we live, based on the family that we have. They mention the names, it gets to stick into our brains and stuff like that. But can a computer do the same? All right, that's the question, because most of the data that will be coming, it will be difficult for human to also analyze. But can we let the computer do that kind of work for us without us human beings sitting down and then writing these programs? All right. So what naturally happens when it comes to machine learning is that we give a lot of data points, right? A lot of data which is relating to, say, cat, right? If we want to in future predict cat among some other animals, right? We give a lot of data points which are related to cats, right? We feed these data to the computer, and then we feed some of the data points which are also not related to cats. Then we say that, okay, these are some features of cats, these are some non-features of cats, so figure it to yourself. So the computer will analyze these data points, right, which are relating to cats, trying to figure out this feature, feature, which is maybe the ears, the kind of ears that a cat is having, the eyes, maybe it's having some hair on the nose, right? The computer will just figure out these features, and then it will compare it with the other non-cat features that we also fed into the computer. Then it will compare the two. Now later on, if it sees different data points that are coming in, right, which is containing different features from different animals, then it will be able to figure out the cat feature out of it. Then it will identify a particular animal as a cat and some as non-cat. All right, like if you take, for instance, here we see a dog, and then we see a dog, then we see a cat among them. All right, now the machine has learned some features of a cat. All right, so it will compare the features with this dog and then see that no, it doesn't match. It will compare with this one, to see that okay, this one match. It will compare with this one, then they see that it doesn't match. All right, so it will call this one a cat based on the data that we fed into the computer. All right, so what data that we have fed into the computer, this will become an algorithm here. All right, we will call this one an algorithm, right, or a model. Right, we call this a model. Then later we will get this new data, right? This is the new data that will be coming in, which will comprise of dogs and cats and some other animals, right? So if we feed this data into this algorithm that we have already there, then this algorithm will figure out and then give us those that are cats and those that are not, cats, right? Based on the data that it has learned from. All right, so basically that's what machine learning does. It helps us to simplify the work instead of sitting down to write a code. Now, if you're using, let's say, C++ or Java to just write this code and make the machine analyze this and later on predicting this is going to be a very tough job for you. It's going to be a very, 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 huge work to do, right? It's going to be very, very complex. But and just imagine the number of codes that you write. But in Python, in machine learning, it simplifies things for us, all right? And that's why this is becoming more popular compared to other traditional languages like Java and the C++ and the others, all right? And when we talk about applications of machine learning, we've seen it all over us, right? If you just think about Uber, you can think about the likes of Tesla, you can think about Zomato, everywhere. All the IoTs that you can see in your homes, most of them are, applications of machine learning, right? If your microphone is on, please mute yourself for me. Yeah. So most of these devices are being, make use of machine learning, okay? If you talk about, say, banking, right? If we talk about banking, let me go back here. Yeah, bring my pen. Okay, if we talk about banking, right? You can imagine the number of times that hackers will try to hack a certain bank, trying to get people's account, I mean, credit cards, numbers, and others, all right? Think about the ATM and something like that, right? It hits them over and over again. But with this machine learning algorithms, we're able to detect them on time, all right? We're able to detect them on time as the signals come in. We're able to detect them based on some past activities like that. We're able to detect the ones that will come and then see that these activities are fraud, these ones are not fraud. Okay, and this is quite huge when it comes to the banking system, right? Even if you can think of this COVID-19, right? Most of the solutions that are coming out is making use of artificial intelligence and machine learning in particular. All right, so this is very I mean, intuitive. Recently, that's why I mean data scientists have become the #1 job since 2016 up to now. I mean, because most of the traditional work that we used to do have been automated, all right? Thinking of the customer service system. I mean, those things are going down, and now you can build just a bot to interact with your customers without you going, I mean, physically hiring someone to do those kind of work, and it's cut down cost, all right? So there's a lot of applications of machine learning, and we can see it all over us. All right. So if you're taking a career in machine learning, then you're on the right track. All right. If you're looking for future job, then you're on the right track. Now let's talk about how we can do this machine learning. Okay. There's two ways of doing it. I just categorize it into two ways. Now you can think of it as a skill that you can build and then start using it, all right? What I mean is that you can actually build the models by yourself, okay? You can learn the concept, know it very well, build the models by yourself, right? Build every algorithm from scratch. And most, I mean, some of the companies do that. They hire people who really know the concept, who can actually build the algorithms or the models from scratch to, I mean, to customize it and then make it suit the business problem, right? Because maybe they have the company is having their own problem they want to solve. So they want someone who can build these algorithms to solve this problem. And you have to build it from scratch, all right? And there's, so this, let's name that
It's
one
9
this
o'clock.
part, right? All right, you build your own custom models, right, from scratch. And then there's a part that you can actually use the one that is pre-trained, right? If you go to Amazon SageMaker or H2 or AutoML, right, Data Robot, they all have algorithms which are already pre-trained there that you can actually use, and then you can even customize it to suit your company goals. All right, but even if you want to do that, you still need to know the concept before you can actually use it, right, to customize it to suit whatever company that you are working for. Okay, so as I said, we have two ways of doing this. All right, it's either your company or let you. I mean, they are having this third-party system like the Amazon SageMaker that they actually lean on, and then they get the models from there which are already pre-trained, and then you supervise that, but you still need to get understanding of that, or you actually have to build everything from scratch. All right, and building it from scratch is not one person's job. It's kind of a team, right? It's going to be a whole team that you actually going to build with. All right, and building it from scratch, you need to be creative, all right, and you need to be innovative. Okay, you need to be creative and you need to be innovative. Because if you think about a Netflix, right, it's innovation and then creativity that made Netflix what it is today. All right, building everything from scratch like that is kind of innovative and creativity. Okay, so that is the two ways that you can actually do it. So as you start your career in machine learning, the first option that you have is to actually learn the concept first. All right, get to understand everything, get to understand what the models, what each model is used for. If you get a problem, what model are you going to use? And how are you going to build the algorithm to solve the problem before you even think of using the pre-trained one, right? Because this one is like already baked. cake that you're going to use. But if you don't know what you're going to actually, if you don't know how you would twerk this to solve, suit your business problem, then it's going to be difficult to use. All right. So you need to really start learning it by yourself, getting to know how the things work before you even think of using the likes of Amazon SageMaker and AutoML. All right. Guys, is the voice breaking? Is it okay before I move on? Can you hear me, guys? Okay, all right. So let's move on. So as I said from the beginning, we are going to concern ourselves mainly on machine learning, right? And in machine learning, we are going to deal with a lot of concepts. So in machine learning, we will actually talk about unsupervised, right? Unsupervised learning. Then we will talk about supervised learning, and then if time permits, we'll go to reinforcement learning, or otherwise we can merge it. We can actually merge it and then see how we can deal with this part. But mainly, most of the concept here, we will merge it with, we will divide it into two, unsupervised and then supervised learning, all right? And with all regression and then classification, dimension reduction, clustering, we will deal with all these concepts. All right, we will be dealing with all these concepts, and then the sub concepts that are also there. We'll be dealing with all these concepts. All right, and then we'll be building projects based on these concepts that you can see over here. All right, there's a project on each of them, and we'll be doing its as we move on. Okay, so we will mainly focus on machine learning in here. All right, so as I said, we will divide it into supervised and then unsupervised machine learning. All right, so I've divided the algorithms under supervised and then unsupervised learning so that it will be easier for you. In case you see the problem statement, you will know that if you identify that this problem is unsupervised learning, then you need to know which algorithms or which kind of models you're supposed to build, right? And what are you supposed to use? So the first thing is to identify the problem as supervised or unsupervised, right? Now, if you're able to identify that, then after that, you can actually know what you're supposed to use, all right? Either you're going to use one of these or you're going to use one of these based on your problem statement, all right? So we will start with supervised. So as I said, we will divide it into unsupervised and then supervised. So we will start with supervised learning here, okay? Now, when we talk about, let me bring my pen, yeah. When we talk about supervised learning, what we are saying is supervised learning is when the model is getting trained on what labeled data, right? We have our labeled data sets here, right? That's what we are going to build the supervised learning on. And then we will talk about the labeled data set so that you get to know what is the labeled data set. So once you identify the problem as a supervised learning, then as I said, you will know which algorithm to choose or which decision to take after that. Okay, so let's try and then get to know what's a labeled data set and then the unlabeled data set, because that's what we are going to actually use to differentiate the supervised and then the unsupervised learning problems. All right, so if you get to know that, then I can say that 20% of your problem is solved, and then the rest is which algorithm to build, which algorithm to use, and then arrive at your solution. All right. So supervised is dealing with labeled data. So let's see what labeled data is, right? And then if supervised is dealing with labeled data, then you can guess that unsupervised will be dealing with unlabeled data. All right. So let's try and then see what this means. Now, if you can see on your screen, right, we are talking about label and then unlabeled data. All right. Now, if you can see on your screen, guys, can you see my pen?
Yes.
Oh, You can see my pen. Okay, okay, good, good.
No,
So we are
your
talking.
you can see your cursor, not.
Oh, okay, all right. Just 1 minute. So from the beginning, you were not seeing my pen, or it's just now? Oh, right from the beginning. Seriously. Oh my God. I've been writing a lot. Okay, let's move on. Let's move on. Let's move on. Sorry for that. Guys, if you're not seeing my screen, if the voice is breaking, let me know as early as possible, because I've been writing right from the beginning, and it's painful you cannot see my pen. Oh. Okay, so we've been talking about labeled data, right? We've been talking about labeled data and then unlabeled data. I hope now you can see the pen. Okay, so if you can see what is on your screen here, right? If we have some apples here, and then we have some oranges here, right? We have some oranges over here. We have some apples here. Okay. Now this is labeled because we know what it is. We know the name for it, right? We know that this is called apple. We know that this is called label. But if you see what is on your right here, right? How can we identify what it is? This is what, and this is what. We don't actually know. We have no clue what this is. All right, this is unlabeled. It has no name. So just think about label as a name that we are giving to it, right? All right, this is unlabeled, right? So this is labeled. These ones have name, right? They have name. We can identify them, right? They have something we can use to identify them, right? So if a new thing comes in, right, and it looks like this, and it looks like this, right? Now we can see that this one is similar to orange, all right? So we can now group this one among oranges, all right? However, if something comes in which looks like something like this, all right, we can see that this one is more like an apple, then we can just group it like an apple. All right, so this makes it simple, okay? But in this case, if something comes in like this, we don't know whether we should put it among these ones or we should go and put it among these ones, because these ones itself are not labeled, right? They are not labeled themselves. So we don't actually know where we should put them. So this becomes unlabeled data, right? And this is labeled data. Okay, guys, is this part clear? Okay, so let's move on to the next page and then see. Okay, so this is kind of an Excel sheet. Now, if you see the Excel sheet, right, we have these column names over here. We have some age, job, marital, education, default, balance, housing, loan, contact, blah 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 blah, all the way to the target, right, where we have the target column to be no and no 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 no, some yes over there. All right, so this is the labeled data, right? Why is labeled data is because if we want to build an algorithm on this, we've been given some features here, right? We've been given some ages, some jobs, some marital education, other features here, right? Now, what we want to do here is to determine whether a client would default, right? Whether a client would default on the loan or not. All right. Now, we already know that some clients are defaulting, some are not defaulting. Now, if you can see the default part, right, the default column, you can see that some are no, 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 no. Now, you can see the target part, right? The target part, some are yes, some are no, some are no, some are no, right? Now, you can see that we have something that we can compare our results to. right? This is some kind of a data that we can feed to the computer or to the machine to learn from, right? Learn from all these features that we are giving you, from the age of people, from the job status of the people, whether the person is employed or unemployed. Is it having any impact on the way that they will come for the loan? Just learn from this data that we are giving you. That's what we want the computer to do. All right. So we feed all this data to the computer. Then the computer will figure it by itself, and then give us a certain status code that if something new comes in, we will compare it to it. All right. So if the computer learns from this and then get to know that, okay, if the person is a student, all right, if the person is a student and the person is single and the person is in secondary school and maybe some other the person's age or something, right? If that person is having these characteristics, then it's likely the person will default, right? It's likely the person will not pay us the loan back, all right, due to the past data. This is the data that we have given to the computer. So this becomes the past data. So if new data comes in, it will compare, right? If there's another student who is also coming for a loan, then we get to see that, okay, it's likely this, if the person is a student, the person will not pay us back, so we will not give the loan to the person. All right. However, if the person is employed, right, like self-employed or entrepreneur, the person is married, the person is having tertiary education, right, something like that, then it's likely the person will not default. So we will give the loan to the person. All right. This is based on the data that we already have, just based on our experience, right? So the computer will figure it out this way. And then if new data comes in, it will predict that this person will pay the loan or not. All right. So basically that's what the computer will do. So this is kind of a label data. It has something that it will compare to. But when you think about the unlabeled data, there will be nothing to compare to. It will just build the algorithm and leave it there. All right, so that's when new data comes in, it will based on the algorithm or the set of rules that we have to just whether classify a customer to a certain cluster or a certain segment or something like that, right? In that case, we don't have anything to compare with. We just want to set some kind of standard rule. We just want to build the algorithm just like that, but we are not building it and compare it to something. But when it comes to the label data, we build the algorithm and we compare it to the past data that we have. All right. So let's move on. Yeah. So when you think about the supervised learning, right? In that case, we have something that or a label that we want to arrive at, right? So this becomes something we call the dependent variable, right? Becomes something we call the dependent variable. Okay, and then this x here, right? This x here will be representing the new data that will come in. So based on this data that will come in, we will be able to predict this x. All right. So maybe this x will be a characteristic of new customer coming to the bank for loan, right? This will be some characteristics, maybe the age of the person, the marital status of the person, the employment status of the person, data like that, right? We will feed it in, and then we will predict whether the person will pay us back or will not pay us back. Okay, so this one will be our target variable, right? And then this one will be our data which is coming in, which will be an independent variable. Okay. So we will start with a supervised learning, and then we'll be dealing with a lot of stuff. So as I said, we're getting ourselves familiar with some of the concepts so that when we get to the Jupyter notebook and doing some practical hands-on, we will actually get to know the concept, right? We will not be new to the concept. So we have what is called train data and then testing data, right? So when we have our data sets, right? Let's say we have, let me bring my pen back. Let's say we have 5,000 data points, right? We have 5,000 data points, okay? In this case, we will divide this 5,000 data points, right? Based on our own intuition, maybe into a ratio of 70, 30, right? And then we use 70 to train the model, all right? We use 70 to train the model, and then we use 30 to test the model, right? To test the model that we have built. So the data that we have, we use some of the data, right, the majority of it, to perform the training, to build our algorithm. Then after that, we reserve some small part of it, about 30% of it, to also use it to test the model and see how well our model is performing. Okay, so this, the one that we will use to build our algorithm actually is what we call the training data set or the training set. Okay, and then what we will use to test the algorithm to see that our model is actually working is what we call the test set. All right, so we'll have the test sets and then we will have our train set. Okay. Okay, so if you can see this, we will talk about the fold. I mean, we have something we call the K fold, right? We'll talk about that later on in the course when we're talking about cross-validation. But for now, just think about, let's say this is our data points. Let me pick, okay, green is fine. Let's say this is our data points that we have. Okay, all these are data points. Okay, now we would divide this into training and then testing, right? So let's say we pick just 1, 2, 3, 4, right? We pick this 4 as our testing data. Then the rest of these becomes our training. So we use all these to train our data, our model, right? We use the rest of the blue to train our model. Then we use the red to test it after the model is being trained, right? And this is done randomly, all right? We choose this randomly. And there's a function to do that, okay? So when we go to the Jupyter notebook, we'll get to know that. All right. So the same way, if it can be, not necessarily that to pick the first 3, right? You can pick some 4 somewhere in the middle or somewhere like that, or maybe the last one. You can just pick it. Just pick it randomly. All right. This data is divided randomly. Okay. Okay, so let's talk about model overfitting and then underfitting. Mostly with all the machine learning interviews and everything, it's like a thumb rule. They will not end the interview without asking you what is a model overfitting or model underfitting. All right, so let's just try and then understand this. So we will build our algorithm, right? Now, after building the algorithm, we use, as I said, we would divide the data set, right? Let me bring this pen. Okay. We will divide the data set into maybe into 80, 20, right? Into 80, 20. And then we use the 80 for training, okay? Okay, we use the 80 for training and then we use the 20 for testing. Okay, so after building the algorithm, right, using this 80 to build the algorithm, now we have our algorithm or we have our model ready. Now we use this 20 to test to see how well this model is doing. All right. Now if we test it, right, and then we see that the model is not even performing well on the training that the model that we have, right? First, we can actually, even in the 80, we have something also called validation test, right? So even in the 80, we can still divide it into say 60, 20, right? And then before we even use this 20, we use this 20 to test it, right? And this 20 is part of the one that we use to build the model. Now we can identify that the model is not actually capturing the data points very well, right? The data points is just scattered somewhere else. When we draw the line of best fit, right? We draw the line of best fit, we can see that it's not capturing the data points very well, all right? Someone is posting a question. Can you explain more on folding the data set? Okay, I said that we have something we call K-fold, right? And we use that when we are dealing with cross-validation, right? When we get to cross-validation, we deal with K-fold. So K-fold is not actually here. So when we talk about that fold, let me just give you an overview of it. We will be having the data points, right? But if we want to perform validation on the data set the model that we have built, like this one, we are just using 20 to build it. To test it, right? But when it comes to the k-fold will divide our data set into number of fold. The k just represents the number of fold, the number of divisions you want to divide your data. Maybe you want to divide it into say 10, right? So if you have like 200 data points, then you divide it into 10, right? So you have 10 different random data points, right? Then for the first one, it will choose some of them as training, then it will just use the rest as testing, right? Then it will go to the next one, maybe choose in the middle, and then use this and then the rest to also build the algorithm. So when we get to the cross validation, we will get to know how these things work. But k-fold is a concept in cross validation that we use after the model has been built. All right. So in the beginning like this, you're not going to use k-fold. K-fold is not here, but it's after the model has been built. What I use, I showed you earlier on, right? If I should just go back one more step. Yeah, what I showed you earlier on is that we will be having data points, and then in the data points, we will divide the data points into training and then testing. All right, we will use the large part. So let's say large and then small. Okay, large and then small. So we will use the larger part. So if you can see here, the larger part is the blue, and then the smaller part is the red. So we use this red to test it after we have built our algorithm on the blue. All right. So this k-fold division of the data set is actually will come when we are doing cross validation. All right. So it's not going to be used. I just want you to see how the image is being done and how we divide the data, how the randomness is being done, how we select it. Right. So it could be selecting it from anywhere else. Right. The testing could be selected from anywhere else, and then the rest will be used to build the algorithm. Okay. Okay. So you're talking of how the criteria for selecting the K. Okay. Let's not divert this into K-fold, because K-fold and cross validation is another topic that we'll be dealing with. Otherwise, we will end up dealing with K-fold and then leaving what we are doing today. All right. So let's hold on to it. When it comes to cross validation, we will deal with that. Okay. Otherwise, we will end up diverting from what we are doing right now. Okay, so let's talk about the overfitting and the underfitting. So what I was saying is that you can build the algorithm, and the algorithm will perform poorly on even the training data that you have at hand. What we want to do is that we want to build the algorithm so that it will perform well on new data that is coming, right? The unseen data that is the algorithm has not seen before. We want our algorithm, our model to perform well on that data. But if you build the algorithm and even the data that you used to build the algorithm is not performing well on that data, then your model is underfitting, right? It's not able to capture most of the data points, all right? It's not able to capture most of the data points. What we want to do is to minimize the distance between each point and the best fit line. All right, so if there's a larger distance between the best fit line, then you can see that your model is actually underfitting. All right, now if you can see this one on the right hand side, you can see that this model is trying to capture every data point, right? It's trying to capture every data point over here. And this one is what we call overfitting. All right, it's overfitting the data that you have, right? It's trying to capture everything. But when you use this algorithm on production, a new data comes in, right? It will perform poorly on the new data. All right, it will not be able to perform well as it is performing on this trading data or testing data that you have here. All right, it's actually capturing every noise that is having here. Every irrelevant thing that is not supposed to capture, it is capturing, right? The noise in it is capturing it. It's just trying to perform as much as it can. And in doing so, it's capturing a lot of things that it's not supposed to capture. All right. So in this case, we see that it is overfitting. We actually want a model that can generalize, right? When new data comes in, it can actually fit that data also. Not that it will fit on the training data that we have at hand and then perform badly on new data. We want to build a model that is general, that is more general. And when new data comes in, it will be able to fit that data also, and not only fitting on the data that we have at hand. All right. I hope this part is clear. Okay, how to measure if a model is underfit? Okay, we will do something like that, right? We will do something like that. So that's why I said there's something called cross validation. When you build, after building your model, you need to validate and see how your model is doing. So we talk about that. All right. So let's talk about dependent versus independent variables. All right. So if you see this equation over here, right, we can see y here, right, and then a function of x. Okay. Now we can think of x here as some data points that we are using, some features or some characteristics. Okay. If you think of this x as maybe a student, all right, a student who will go for a loan in the bank, right? Now this y here can be whether the person will pay us back, right? So let me see, will pay or not pay, right? That's what we want to predict, and that is what is represented with y here, all right? So this x, is someone speaking? If you're not speaking, please mute your microphone so that I will not get a feedback here. So you can think of this X as the characteristics of the student who is coming for the loan, right? Maybe the person is single, right? The person is single, the person is unemployed, all right? The person is unemployed. The person is having some other medical bills or medical conditions, right? So with all these, right, we can see that, okay, with all these, yeah, okay, to just mute yourself. So based on this data that we have, right, we can predict that whether a student will actually pay us back when we give the loan or not. And based on this output, we can take a decision whether we are going to give the loan to the student or not. So this one, which is depending on the characteristics here, right? This Y, which is dependent on the characteristics, because this can be a student, it can be, let's say, a manager, it can be a different person, it can be a doctor or something like that, right? And they all have their different characteristics. So this, based on this characteristics, is how we are going to predict this output, all right? So this output is actually depending on what is here. So this is what we call dependent, right? This becomes dependent variable, right? Because it's depending on this, and this is not dependent on that. So we call it independent, all right? We call it independent variable. Okay. Okay, so we are actually going to talk about regression, right? We will start with regression, and then we will move on to other concepts in machine learning. So we first start with regression. So previously we talked about correlation, right? We talked about correlation, and now we will talk about regression. So if I should draw this here, okay. Now, if we have, say, a certain variable x here, right, and then a certain variable y here, now we can find a relationship between this x and then y and see how they are correlated, all right, and see how they are correlated. Now, if we find a correlation, whether the correlation is negative, all right, or let me undo. Okay, whether it's negative or it's positive, right? Whether the correlation is negative or positive. Now, this is what we call the correlation, right? So correlation will actually help us to know the relationship between the two variables. Okay. Now, what regression will help us to do is to use this relationship to actually make future predictions. All right. So yeah. So regression will help us to use this to actually make future predictions. Okay, so that's basically what we are going to use regression for. Because if you find a correlation, it's just there, right? That's the only information that you get. right? That's Y is correlated with X, whether positively or negatively, or maybe there's no correlation in it, all right? But can we base on that and then make some future predictions? That's when regression comes in, okay? So we will start with linear regression. Actually, we have, with the regression, we will divide it into two. If you see the previous slide, we will talk about linear regression and then logistic regression, okay? So now we will start with linear regression, okay? So before we even go to the notebook, let me show you something here. Okay, let me use this. Oh, someone's microphone is on and it's giving bad feedback, please. Okay, so let's draw this. Okay, let's draw it again. Okay. All right, so let's say we have two variables. We have X here, right? We have X here, and then we have Y here, all right? We have X and then Y here. Now, we can see this as a two-dimensional space, all right? We can see this as a two-dimensional space. So this part is actually the independence, right? Our X here, our S down here is independent, okay? Let me write it over here. It's an independent variable, okay? And then this becomes a dependent variable. This is our dependent variable. Okay, so let's just pick any values for X and then Y. All right, so let's say we have X here, we have Y here, okay? Let me just draw this. Okay, so let's just pick 1, 2, 3, 4, 5, right? And then pick 1, 2, 3, 4, 5 here. Okay, now if we want to make a prediction, right, that we want to draw a line for, a regression. No, let's start with correlation and see the correlation between X and Y before we even talk about regression. All right, so let's start from here. So that we have 1, we have 2, we have 3, we have 4, and then we have 5. The same goes to Y, 1, and then 2, we have 3, we have 4, and then we have 5. Now, if we see it from the table, right? When X is 1, let me change this. Yeah. When X is 1, Y is also 1. All right. So 1, 1. That will be somewhere here. Okay. When X is 2, Y is also 2. When X is 3, this is also 3. And then 4. And then say 5. Right. Now, if we want to draw a line, if we want to draw our line, then it will go through this. All right. It will go through this. So let me go back. Okay, now this is what we have, right? This is what we have. Now, if we think about the correlation between X and Y, we can say that it is positively correlated, right? X and Y are positively correlated. So if I write X, Y, right? They are positively, let me use just plus, right? Positively correlated, okay? Now, what regression does is that after you've seen the relationship, right, between the X and then the Y variable, that's the relationship between the independent and then the dependent variable. Now, what you can do is to make future predictions, right? So if new data comes in, right, say 6, right? New data comes in 6. Now we can predict that from this part, right? We can now predict right? We can now predict the y value from the new data, from the new x value, right? We can now predict the new y value from the new x value, and then we say that y will be 6. Okay, so that's when regression also comes in. All right. Now, if we want to write an equation for this, right, then it is going to be like y is equal to x, because whatever y is, the same thing is for x, right? Y is equal to x, y is equal to x. Is that correct? Okay, so we can write an equation like this as y equals s. Now, if we can also write this as y equals let me pick this, y equals 1. Okay, y equals 1x. Okay, we can write this, which makes no difference. All right, which makes no difference. Now, this one, right, this one can actually vary, right? This one is nothing but the slope, right? It's just the slope, right? So this one will be changing x, all right? Changing x, and then here will be changing y, all right? So the change in x, all right, the change in x divided by the change in y. All right, this is what this one will represent. And in our case, change in x is the same as change in y. So in this case, we are going to get 1. All right. But if we have different data points, right? If we have different data points, then this will not be the case. Okay, this will not be the case. If we have different data points, then this will not be the case. Okay, so since we don't know the future number that we write here, the future slope that we will write here, we can represent it with a certain letter, let's say m, right? So we can just write mx. Okay, we can just write it as mx. Since this m can be different, let's say these numbers are not 1, 1, 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. They are different numbers altogether, right? Then the slope will not be 1, it will be different. But since we don't know the numbers that will be coming in, instead of this writing this 1, right, we are representing it with just a letter, so that whatever slope that we will get will be represented here, right? Now, if you see this one here, now this is passing through the origin, right? And the origin is 0, 0. Right? It's 0, 0. And this is because the data points, I mean, the distance between them are all the same, right? The slope is the same, and that's why it's passing through the origin. But if we have a different data point, let's say, let's just change this. Let's just change this data point and then see. Let's say this one is 0, all right? Then we have, say, 1 here. Then we have 2 here. And then we have 3. And then we have 4, all right? Now, if we do this, right, then we will have a different line, all right? When x is 0, let me just draw it again. Let's say we have x and then we have y, all right? So we have 0, 1, 2, 3, 4 here. Then we have 1, 2, 3, and then 4. Let me go up a bit. Yeah. Then we have, stand this. Then we have 5. Okay. Now, if we draw this again, and then we have 1, 2, 3, 4, 5, right? We go to y, and then we have 1, we have 2, we have 3, we have 4, we have 5 here. Okay. Now, when x is 0, y is 1, all right? So this part is 0, 0, right? This is the origin, which is 0, 0. When x is 0, y is 1. So we have our first point somewhere here, okay? When x is 1, y is 2. So that comes somewhere here. When x is 2, y is 3. So that comes somewhere here. And then when x is 3, y is 4. Coming somewhere here. When x is 4, y is 5, right? So coming somewhere here, all right? Now, if we draw it again, we draw this line again, supposed to actually pass here. Okay, now just assume that it's passing through the point. Now, if we draw it here, now you can see that it's not passing through the 0, 0 again. Now it's passing through 1. So our equation here, right? Our equation here will not work. Now, if we use this equation as y equals mx, right? And then we assume that the distance is 1 here. Now, if we put x equals 0, right, that will be 0 times 0, and then y is supposed to be 0. But in this case, y is 1, so this is wrong. All right, now if we put, say, x equals 1, then we have 0 times 1, all right? And then y is still, 1 times 1, that is the difference, right? Then y is supposed to be 1, but here y is equals to 2. The same thing equals, applies to the 3. If we say x equals 3, then it will be 3 times the 1, and then we are supposed to get 3. But over there, when x equals 3, y is equal to 4, okay? So you can see that in this case, it is our y value is being increased by 1, right? See, being increased by 1 as compared to the result that we are getting here. We got a result 0, but it's supposed to be 1. We got a result 1, but it's supposed to be 2, which is 1 more. We got results 3, but it's supposed to be 4, which is 1 more. The same thing if we do for the 5, we'll get this results to be 4, but it's supposed to actually be 5. All right. So we have to actually modify our equation. So instead of y equals to mx plus, mx, right? Now we can add 1 to it, right? So that it becomes mx plus 1. Okay, so this becomes the equation for this that we are having here. Now, if we want to generalize this, right? If we want to generalize this, now we don't know the difference or the other additional points or maybe minus that this y will need. Maybe it will be less, it won't be, plus, all right? So if we want to generalize it in that way, then we need to have a general formula for it. All right, so instead of the 1 here, we can just replace it with any character. All right, so that it becomes a general formula. Okay, so instead of y equals mx, all right, plus 1, okay? Instead of that 1, we don't know in future what that 1 will be. Maybe it won't be plus 1, it will be plus 2. We will need plus 2. Maybe here will be 3, and then we will need plus 2. Or here will be 7, and we need by more than 2, all right? So instead of the 1, we are going to add a constant c, right? And this c is nothing but where the line passes through the y, right? So normally we call it the y-intercept, all right? So this c becomes the y-intercept, okay? This c becomes the y-intercept. So now this becomes this y equals mx plus c, this whole equation, right? This equation becomes the equation of the line, right? It becomes equation of a line, or you can call it a linear equation, right? So based on this equation is what we are going to build our algorithm on, right? So basically, even if you give the, you are building the algorithm, this is basically what it's trying to do. It's trying to find a general rule that it can use for all other data points, all right? So in this case, we start with y equals x, all right? Then we see that, okay, not every time that we are going to have 1, it might change. So we put, instead of 1, we put m there, all right? Now, when we move further, we see that, okay, it might be a time that we will need some extra data points. So we added that one as c, all right? So generally what algorithm is going to do is going to find a general rule, all right, that you can base on. So that's basically what building machine learning algorithm is. And this is what we call the linear equation. And we're going to use this one in building other models, right? So now let me just talk about this one more thing before I move on from here. Now, if you can see right here, we are talking of trying to predict y whilst we have some m multiplied by some x value, right? Whilst we have some x, so we only have x and y here, right? We have x and y here. We have our dependent variable and then one independent variable. But there could be a case where we will not have only one independent variable, right? We could be having more than that. right? Now we actually do it in a plane, right? This is a 2D plane. You can call this thing as a 2D plane, all right? You can call this as a 2D plane. Now, if the variables are more, right? If the variables are more, let's say we have another variable, so there will be another constant for it. And then let's say that one will be, say, Z, all right? Then let's say there will be another one, let's say M3. Then let's call this one, say, P, all right? Then there could be another one. You can just think of it, just M4. And then let's say Q, right? Plus other ones that you can think of, right? Now this one becomes a hyper, right? Becomes a hyper plane. Okay, this one becomes a hyperplane. We will see how these variables are. Normally, what happens is that the variables or the independent variables that you're going to use to predict the dependent variable, right, will not be just one, right? It could be one, but normally in the normal circumstance, in the normal real world, there could be a lot of factors that are accounting for a certain output, all right? So when that case happens, then you can think of it as using a hyperplane. Okay. So let's move on and then see what we can do in the Jupyter notebook. I think someone tried to write on his screen, right? So that annotation is here. If you can delete it by yourself over there. Okay, so let's see what we are going to do here. Now we have certain let me bring my pen. Yeah, we have certain variables here, right? We have certain variables here that we will be dealing with in this practical hands-on. Okay, we will be dealing with this one. But before we talked about this, let's go up a bit. Let's go up a bit, then see what we want to actually do finally. Now, if you can see from what I wrote here, building a linear model to express relationship between a car's mileage, right, which is MPG. So in the data set, you will see that there will be some MPG there, right? That's what we actually want to target. That will be our target, or that will be our dependent variable, okay? So that's what we want to actually predict finally. And then the rest of each other attributes. So the rest of it will be what I was talking about as maybe M1, and then say X, and then plus say M2, and then say Q. So these will be the variables that we will use to predict our Y. All right, so here in this case, MPG will be our Y, and then the other variable, which are cylinder displacement, horsepower, weight, and stuff like that, will be the X and the P and the Q that we have over here. All right. So let's start by importing our library. So I think this one we are already familiar with importing the libraries. So we will need NumPy, we will need pandas, we will need matplotlib, and all these, the ones that we are not familiar with. I think matplotlib, we are okay with it. We've done some on it. I mean, even yesterday we did something on it. And the ones that we are not familiar with, which I want you to take note of. Let me zoom in so that you get to know it well. Okay, so the ones that we are not familiar with is this linear regression, right? And we are going to use this linear regression package to actually build our model, all right? So from scikit-learn.linear model, right? From scikit-learn.linear model, we are importing linear regression, okay? Then from scikit-learn.model selection, we are importing our train underscore test underscore split. All right, this is what we are going to use to split our data set. right? So we use this one to split our data set, and then we use this one to build our model, okay? So let's start by loading our data set and then seeing how this work. So if you remember yesterday, we were doing some exploratory data analysis, right? So we are going to do the same thing here. Before you start building any algorithm, you need to explore your data. You need to see how the data is before you start um, building any algorithm, okay? So we start by loading the data set. And if you can see here, we are using pd.read underscore, right? We're using pandas to read it. And then our data is stored in autompg.csv. This data set is in Cargo. You can have access to it. And then we store it in C data, all right? Then we print the first 5 row, and then you can see over here that we have different attributes, MPG, which is going to be our target, or our dependent variable, and then other attributes which are including cylinders, displacement, horsepower, weight, acceleration, model here, and then origin, and then the car name. All right. So we are going to use this data set to actually build our algorithm. So before we do that, let's explore it a bit. Let's perform some exploratory data analysis on it, and then see, get ourselves familiar with this data set. So the MPJ is just the miles per gallon. Then we have the cylinder, the number of cylinder that the car might be having. All right. So some are having 8, some are having others. If I should just increase this a bit, let me just stop printing the head and then print everything and see. Okay. Now, if you can see, we have some are having 8 cylinders, right? Some are having 4 cylinders, some are having 6 cylinders, right? A lot of them like that. Okay. So let me just limit it to the first 5 rows so that we can have a better view of the rest. Okay. And then we have the engine, right? The engine displacement, we have the horsepower, the vehicle weight, the time to accelerate, I mean, from 0 to 60 mph. And then the year the car was actually modeled, right? That's the model year. And then the origin of the car, right? Whether it's from America or Europe or Japan, right? And in this case, they did something, right? The origin of the car, if you can see the origin column here, right? The origin of the car. If the car is from America, they represented it with 1, right? If the car is from America, they represented it with 1. If the car is from Europe, they represented it with 2. If the car is it's a Japanese car, they represented it with 3. All right, so that's what that column has been represented, the origin column. All right, then the last one will be the name of the car. Okay. So let's see the shape of the data sets. We are having 398 rows, right? So we have 398 rows. If we print everything here, yeah, all the way down to 398, right? You see 397 because it's starting from 0 here, all right? So if you count it from 1 from here, then you can see there's 398, right? So 398 rows and then 9 columns, okay? So that's what the shape will let you know. Now we can talk about, we can use the LM plot to actually see the relationship between some of the attributes, right? So now here we want to see the correlation between MPG and then acceleration, all right? We want to see the correlation between MPG and then acceleration. All right, now we plot this, we can see that the correlation is a bit less, right? It's not that correlated. You can maybe think about positive correlation, but it's very, very less. All right, it's very, 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 very less, right? There's a very, very low correlation between MPG and then the acceleration of a car. Okay, so this one will give you, an initial idea that the acceleration of a car is not that related to its miles per gallon, right? And this is the line that we were talking about. Now, if you can see where the line is cutting now, all right? And then we also talk about these points, the distance between these points, right? Distance between each point, and the line of the best fit. And I mean, what's every machine learning algorithm, when it's linear regression or logistic regression, right? What I would try to do is to minimize this distance that is between the various data points and the regression line, all right? To try to minimize it. So we have something we use to measure that, right? And we call it the root mean square, right? So this one here, will be our y, right? Will be our y, and then the rest that we have, the rest data points that we have here, right? So they will represent something we call the y hat, right? So the difference between the y and then the predicted one, right? The ones that came, right? The new ones that came, and then we can sum all of them, right? We can sum all the distance, right, between the y and then the predicted ones, right? So the distance between this point and that point, this point and the line, this point and the line, this point and the line, all of them, all of the points, right? We have the difference between them, right? The distance, I mean, the difference between them is actually called the error, all right? Is the error that we are talking about. Okay, so if we find that error and then we square it, right? Let's say this is yi, right? Right? There are a lot of y's here, y hats over here, and then there's a lot of y's that lie on the main line, all right? So y to this one, right? So maybe yi equals to say 1 to a certain number, all right? So we sum all of them, then we divide it by the total number. Okay, now if we square this, all right, we square this. Now this is what we call the mean squared error, all right? But if you have a little background, in integration, no, differentiation rather, yeah, differentiation rather, you can see that differentiating this absolute value is very difficult, right? So in that case, we use something, we make it, I mean, more closer to the standard deviation, right? By bringing the root, all right? So the root of this to the n, I mean, the same thing that I'm writing over here, all right? So the y hat and then square, right? So this, let me see if I can change it. So this, right, this one here, actually divided by n, yeah. So this one here is what we will talk about as root mean squared error. So when we are talking about validating our model, we will talk about this RMSE, right? The root mean square error. Okay, we will talk about this one too. But basically, I wanted you to, I mean, have an idea about how it is. It's just the distance between each point and the regression line we have here. We measure the error.
It's 10 o'clock.
Right? Then we square it. Then we divide it by the total, and then we find the square root of that. Okay? So that we were able to minimize the error. What we're actually trying to do is to minimize the error. Just minimize the distance between each point and the main line. All right? So let's go down there and then see. Someone posted something. Is RMC is the criteria to decide on best fit line, or is there any other measure? Okay, that's what we I just showed you. If you want to measure the error, we use the RMSC, right? So let's see between the MPG and cylinder, right? Is there any correlation between MPG and then the cylinder of a car? Okay, so if we see the drawing, I mean the graph down here, you can see that it's kind of negatively correlated. If you see the regression line here, it's slanting down like that, all right? So as the MPG increases, and then we have, I mean, the lesser the cylinder, the higher the MPG of the car. All right, so cars that are having higher cylinders, right, higher number of cylinders are having less MPG, and those with lesser number of cylinders are having higher MPG. All right, so I should draw this, you can see clearly. Yeah, so cars with the lesser cylinders, right, say if the car is having 2 cylinders, right, then it's having a very large miles per gallon, right? But if the car is having high cylinder like this 7, right, then it's having it's having less miles per gallon. All right, so this one will give you an idea of a relationship between the miles per gallon of a car and its cylinder. Okay. Now we can see it with the miles per gallon, and then weight. We are using more of miles per gallon because that's our target variable. All right, that's our target variable. That's why we're using more of the MPG, right? And then comparing it with other variables. Okay, now this one you can see that it's more of negative correlation, right? There's a negative correlation here. Okay, so as the MPG, right, the miles per gallon increases, then it's having, I mean, cars with lesser weights are having a higher MPG, all right? Cars with lesser weights, they are having higher MPG, but those with higher weights are having lesser MPG, okay? Okay, so this is the different correlations that you can have. I think this one we talked about in the in some of the classes, right? So if like this, just strong positive correlation is moderate positive correlation, and then if it's like this, then you can see there's no correlation in it, right? And if it's slanting down like that, then it's moderate. If it's not that strong, as you can compare it with this. And something like this is what we call curvilinear. It might be in a form of a curve like that, right? Call it curvilinear. Okay. Yeah, this is what I was talking about up there. All right, the regression line and then the error that is between each point and then the regression line. All right. And we use the root mean square error to measure this. Okay, so let's start by doing something else over here. Let me just zoom it a bit and then get my pen. Okay, now if you can see over here, right, we are dropping the car name, right? The data set is actually having, let me just bring the data set again. Okay, so if we see our DF, let me use seed data, right? Seed data, and let's print the head of it over here. Yeah. Now, if you can see this, we have the car name, right? Now, our intuition, right? This, the person who is building the algorithm, right? So most of the decision that you're going to take, you will take it based on your experience that you have had over and over again, right? In building other algorithms, or based on the domain knowledge that you have, right? Now, what we are doing here is that we are dropping the car name, right? Because what's the assumption here is that the car name will have nothing to do with the miles per gallon, right? The name of the car has nothing to do with the miles per gallon. It's not going to help us to predict the miles per gallon in any way. That's why we are dropping it. All right, that's why we are dropping it. So we use the drop function, if you remember, we use the drop function, and then we say that axis equals 1, showing that it's located in the column. All right, if we use axis equals 0, then we are talking about the row. Okay, so we drop that, and then as I said earlier on, if you see the origin of the car, right, where the car is originating from, sorry, if it is America, they use 1 to represent it, and if it is Europe, the car is coming from Europe, they use 2, and if the car is coming from Asia, they use 3. All right, so we want to change that, right? Otherwise, the algorithm is going to actually see it as a rank. It's going to rank it as, say, cars coming from Asia is greater than cars coming from America, since Asia cars are being represented with 3. But we don't want to make that mistake. All right. There's no ranking between the cars coming from Europe and those coming from America, those coming from Asia. All right. It's just a number that they use to represent the country name. So now we want to use the original country name. So if we see 1, we represent it with America. Okay. If we see 2, we represent it with Europe. And if we see 3, we represent it with Asia. Okay, so we printed the head of it, and then you can see that the origins column, instead of 111 now, is represented with America, 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 and this is just the head. So the rest have been also replaced as well. And this one is coming at the end of it because we specify it here that make it a different column, right? With the same name, but we are specifying it again. That's why it's coming at the end here. Okay. Now, after that, what we are going to do is to convert these names. If you remember from yesterday's class, I told you we cannot actually build an algorithm on objects, right? In Python, if it's a string or character like this, it's represented as object. So we actually want to convert the ones that are objects, right? We cannot build algorithm on it. So we will change the names, right, to a dummy names, and we are going to use the get dummies, right, to represent it. So that, and if you see earlier on, they use 1, 2, 3, but it was on the same column, right? So in that case, it's going to be ranked. But if we use the get dummies, we are going to represent cars that are coming from America on a different column, those that are coming from Asia on a different column, those that are coming from Europe on a different column, right? So if you see the first row, if you see the first row from our original data here, right? The first row, the car over there is from America, so it will be represented with 1, right? And the rest will be 0, and the rest will be 0. But if there's a car which is coming from Asia, right? That car is Asia, so the rest will be 0, right? Which means the car is not coming from America, so it will be 0, and the car is not coming from Europe, so it will be 0. And if the car is coming from Europe, it means that it's not coming from Asia, it's not coming from America. So this part will also be 0. The same way with the others, and if it's coming from America, then it's not coming from Europe, right? So if it's here, if it's coming from America, then the rest needs to be 0. Okay, and if it's coming from Asia, it means that it's not coming from Europe, it's not coming from America. All right, it's coming from Asia, then it's not coming from Europe, it's not coming from America, right? So that's how the get dummy function will actually perform. Okay, so let's move on, and then let me, yeah. So now let's check if there are any null values in here. Now we use the is and a, right? If you remember from yesterday's class, you can see that we perform some. So all what we are doing right now is to get to know, to prepare our data for to build a machine learning algorithm. You cannot just build the algorithm on it. It will just it won't work actually. It will just give you some false output, and you're actually going to find it very difficult to even do it. So you first prepare your data before you build the algorithm. Okay, so what we are doing right now is an exploratory data analysis, right? We explore the data and then we prepare it for, to build algorithm on it. So now we want to see if there are any null values in this data set, all right? Guys, give me 1 minute to let me put my charger in. Okay, so I hope you can hear me, right? Okay, all right. So if you remember from yesterday's class, we actually checked if there are any null values in there. So we used the is and a, all right? Yesterday, I remember we even used a function to check, right? but this is a simpler way of doing it. You can just use the is and a, and then use the sum, right? If you use just the is and a, right? Let me just run this part, and then you can see what just the is and a part will give you. Okay, so let me run it from here. Yeah. Okay, so this part, I'm going to clear out this sum, and then you can see what this part, you see. Now it will be giving you a Boolean output like this: true or false, true or false, true or false. So if there are any null values in there, it will be true. If there are no null values in there, then it will be false, right? A lot of them. But if your data point is very big, you cannot actually eyeball it like that. Besides, it will break somewhere like this one. It will break from 29. It move all the way to 368. So whatever data points are in here, in between here, we don't know whether there are some true there or not. We don't know. But if you use the dot sum, right, then it will check if there is any null values in there. Then it will count the number of null values in there. Then it will output it. If there's nothing, it will give you 0, right? So it will do it for all the columns. So if you can see here from the MPG, it is saying that there's no null value there. If you see the cylinder column, there are no null values. The same thing applies to all the other columns. All right. Now let's see something here. Let's see something here. If we check the data types, right? If we check the data types of each column, right? The MPG is saying that the data type is float, right? Meaning that it's supposed to be in a decimal form, right? Now let's go ahead and see. Let me just maybe it will be better if I print it here. Div, then I print the head of it. Yeah, so we can compare. Now, if you see the MPG column, right, it's saying that it's supposed to be float, right? And if we check, okay, if we check from the data frame, you can see that it's 18.0, 15.0 is in a decimal format. So yeah, this one is good. Now, if we see the cylinder column saying that it's supposed to be int, yeah, and it's 8, and some other data points is integer, right? It's true. Now, if you see the displacement, right, the displacement column is saying that it's supposed to be float, right? It's supposed to be decimal numbers. Yeah, it's true. Okay. Now, if you see the horsepower, right, it's saying that objects. But when we go here, we can see that it's integer, right? They are integers. We are supposed to have int 64 here, right? It's supposed to be giving us int 64 instead of float, right? From the horsepower is giving us float, right? But when we see the horsepower here, it's actually integer values that are there. So why are we getting this, right? So this is what we have to actually figure out, right? That there's something among this column. There's some letters in this column, right? Maybe they represented some names or some letters or some symbols in this column. That's why it's giving objects instead of integer, right? Because you're seeing only the first 5 rows. What about the other rows? Maybe there are some letters or some names or some symbols in there, right? That's why it's giving us int 4. So we need to actually go through and then see what is happening in that column. All right. I think the rest are okay. The rest are okay. Int, float, yeah, int, float, and then this one is giving us int, and then some units, right? So the rest are okay. The rest are okay, but we need to actually figure out why the horsepower is giving us object here instead of int. All right. So let's move on further and then see what we can do with that. So we are going to use this isDigit, right? IsDigit function here to see that if it is a digit, right? If it's a digit, give us true, right? I don't want this plus. Okay. Yeah. If it is a digit, give us true, else give us false, right? If there's anything there which is not a digit, then you give us false. All right, so that's what this part will do. So we perform that on the horsepower, all right, because we cannot go through one by one to find out if there are any letters or names or symbols or whatever is there, all right? Now, when we perform that, we store this output in what is called digits in HP, right? This is just a variable that we chose, right? It could be anything that you can choose, right? It's just a name that we chose. So we perform this is digit function on the horsepower column, all right? Then after that, we check if there's anything which is equivalent to false, right? Which means that which is not true. If it's not true, it means that it's not a digit. If it is a digit, like we can see from up there, right? Let me go up there a bit. Yeah, if you can see, if it's a digit or integer, like say 130, 165, or 150, then it's okay. But if it's a letter, right? If it's a letter or a symbol or anything apart from a number or a digit, right? Anything apart from a digit like this, then you give us false and you give us the output. So that's what we are doing down there. Okay, that's what we are doing over here. Now, after checking it, you can see that in the horsepower column, they put some question marks in there, right? They put some question marks in there. It means that when they were collecting the data points, right, some of the output that they did not get, they represented it with question mark. All right, they represented the output that they did not get with question mark. All right, so this is why this column is actually giving us an object instead of an integer. Okay, so our job here is actually take out this to take out this. So there are several ways of dealing with this. We can actually drop all these. We can actually drop all these, and that should be your last option. Dropping any data points should be your last option, because as soon as you drop, you lose an information. All right. As soon as you drop, you lose an information. So you should be careful with dropping any data points. All right, so what we are going to do over here is to first replace this question mark with NaN, right? Because in Python, if you want to represent not a number, right, a null value, right? Because these are not numbers, right? They are just missing values that they represented with question mark. So we want to represent it with NaN so that we can actually use some Python function to deal with this NaN. Okay, so we use the replace function and then replace this question mark with NaN. All right, so if we move down here further, right, let me just print this one again before we use the mean. Let me see if we printed it. Okay, we did not. So let me print it out so that you can see. Now, df, let me just print everything in there. Okay, first let me run this. Let me run it from here. And then run this. Yeah. Now let me replace it and then show you this. Okay, now if you see down here, right? If you see down here, you can see that there are some NaN here, which means that previously it was question mark. Right now we've been able to replace it with NaN. All right, we've been able to replace it with NaN. Now Python will be familiar with this NaN rather than question mark. It doesn't really understand the question mark, right? There are some functions that we are going to use, but they don't understand the question mark. So we replace the question mark with NaN so that we can deal with it. All right. Now, if we go all the way down here, now what we are going to do is that, as I said, dropping the variables should be your last option, because as soon as you drop, you lose some information. Okay, so we are going to actually you replace the question mark, right? The missing values. We are going to replace the missing values with the median of each column. So we will go through each of the columns, and as soon as we encounter a missing value or we encounter NaN, right, we replace it with the median. All right, we replace it with the median. That's what we are going to actually do. All right, if you remember that we say that the mean can actually be affected by an outlier and then higher ranges, right? So we prefer replacing it with the median instead of the mean of each column. All right, so let's check the mean of each column. If you can see the MPG column, the mean is 23. Cylinder is having a mean of 4. Displacement is having a mean of 148. The same thing happens to all the others, right? So we check it here. Now, what the function that we are going to use to replace this is what we call the fill NA. All right, we are going to use the Python fill NA, and then we are going to fill each of the column with the median. Okay, so to go through all the columns, right? To go through all the columns, and then if it encounters any an there, it will replace it with the median of that column, right? So if this is say MPG column, right? If this is MPG column, then the MPG column is having a median of 4. So if it goes through this column and then find NAN, then it will replace it with 4. Let's say this part is say horsepower, right? So if it goes through the horsepower column and then it finds any NAN there, then it will replace it with the median of the horsepower column. Okay, so that's what the fill NA is actually going to do. Okay, and this is an alternative way of doing it, just using the lambda function to also do this. I mean, fill it with the median in the same way. All right. So let me move down here and then see. Okay, now after checking the type, right? After checking the type, now we can see that the horsepower column is now a float, right? The horsepower column, come on, yeah. The horsepower column is now a float, right? Instead of an object, it's now a float. All right, so which means that instead of the question mark that were causing us to see objects, now it has been replaced with NAN, and then further on, the NAN has been replaced with the median, right? Which could be decimal, right? It was 4 point something, right? That's why now we're having a float over there. Okay. Okay, so we can also use the pair plots and then actually see the relationship between each point. So we will not spend much time on the pair plots. I think, let me close this, but yeah. I mean, the pair plots is actually giving us the relationship between each of the variables, which we have already explored up here, right? Which we have already explored some of them up here. So this is just another correlation, like cylinder. If you see cylinder and then displacement, right? You can just use the upper part, and then you can see cylinder and displacement. The displacement is negatively correlated. And then I said yesterday, I told you we talk about these peaks, right? This is just giving you an idea that there might be about 3 clusters in this data point, and then when we're talking about maybe clustering, could be an important information. All right. So yeah, then you can see some of them being positively correlated, and some of them having no correlation at all. All right. So this is just the same thing that we explore up there. Now let's come to this point, which is our main goal today. So let's start by building the algorithm. All right. So now this is our data that we have prepared. All right. This is our data that we have prepared over here. Let me try and see if I can zoom. Yeah. This is our data that we have prepared. So we are going to build the algorithm on this data set. Okay. We're going to build our algorithm on this data set. So I just printed the head of the data set here for you to see, right? And then we're going to divide the data into independent and then dependent. This is supposed to be A. Yeah, independent and then dependent variables. All right. So our target is actually MPG. All right. Our target is MPG. So we use that one as Y. If you remember the linear equation that we saw earlier on, it was Y equal to mx plus c, right? So our y is the dependent, right? That's why we store it in the variable y. And normally we use small y and then capital X for the dependent variables. I mean, it's just your preference, right? You can just use small for all of them. Okay, so we store the MPG, which is our target column, in y, and then the rest of them in X. Okay, the rest of them in X. And then since we don't want to repeat this MPG there, we just drop that. Okay. And then the origin part too. Now, this is the part that you need to, we have not done. So let's try and then see what is happening over here. Now, if you see this, earlier on, I was telling you that you'll be having your data point, you need to divide it, right, to training and then testing. That's what this part is actually doing. Now, in this case, we're having about 300 and something, right? About 300 and, I don't know, whether 98 or something like that. Now, we are going to divide this into 70, 30, right? Into 70-30 ratio, right? That's what we are going to do over here. 30, we use the 70 part of the data set, right? 70% to train the model, right? To give this 70% to the machine to learn from the 70% of the data, right? The larger part of the data. And then we use only 30%, which is the smaller part, to test it, all right? To test the model that we will build finally. Okay, so that's what this 70-30 is doing here. So you can see that we are dividing it into X train, X test, and then the Y train, and then Y test, all right? Then we use the train test split. If you remember earlier on, let me go up here, all the way here. You can see that we imported this train test, right? Train test split, right? So this package is what we are going to use to actually divide the data into 70-30, all right? And dividing it into 70-30 is just based on our own intuition that we are using, all right? There's no thumb rule to use. It's just based on you who is building the algorithm, all right? So yeah, we're here. So we use 70% to train, and then we use 30 to test, right? So I mean, this test size, right? That's a test size that we want to, that's 30%, all right? And then the random state here is just showing that, as I said, this 70 and 30 are being selected randomly, okay? It's being selected randomly. And then we are setting the state because we don't want to, if we run this algorithm, we don't want to change the selection again. We want it to be consistent, all right? Otherwise, if you run this algorithm again, it's going to select different, it's going to reshuffle again and then give us different random variables, which we don't want to do that. We want consistency in our model. So that's why we use the random states, right? We just set the random state equals, I mean, any number. And then when we run it again, it won't give us any random numbers again, all right? So after that, what we do over here is to initialize this function here, which is the linear regression. If you remember up, yes, hello?
I just want to know why did you drop only two independent variable, like in here I can see you drop origin of Europe and
Yeah.
MPG.
Okay, I just, for Europe, I just drop it because I just wanted to minimize the data, all right? So I could have dropped other countries also as well. But the MPG is a must for me to drop it, all right? Because the MPG is the data that I don't want my algorithm to see, all right? I don't want my algorithm to see initially. I'm actually going to use it later on, but I don't want the algorithm to actually see it initially. I'm actually going to use that one as my Y here, right? I'm going to use that one as my Y, which I mean as my target, So this one will be my target over here, all right?
So
But I cannot put all the targets and then, I mean the dependent and then the independent all here. Now all of them will, are going to be, what do you call it? I mean, the reshuffling wouldn't work that way. Like you're supposed to reshuffle and then evenly shuffle and then select random numbers, some from the target and then some also from the independent variable, all right? So that it will learn from both sides and then build the algorithm.
so the independent variable must be plotted along y-axis, right? In x-axis, right?
Okay, so it's like this. It's like this. And then we have our X here. Then we have our Y here, right? So this part is independent. Just think about here as in. Just think about here as D, dependent.
Okay.
Okay, so here is D, dependent. Here is in,
Oh,
independent.
okay.
Okay, so this part, right? So we first, if you are familiar with some OOP concepts like object-oriented concept, you just initialize it, right? That's what we are doing here. And then, so this is a linear regression package that we are going to, function that we are going to use to build the algorithm. So we just initialize it into any variable. So this one is just a name that I chose. You can just even delete the regression and just name it as model or anything else. Any name, right? And then after that, we are using that variable that we use, we named over here, right? We are using it as the regression model, right? This is just the same name, dot fit, right? Dot fit is the new thing that we are having over here, okay? Close this here. Dot fit is the new thing that new function that we are having here. Now, what dot fit is doing here is that we are seeing that learn, right? Basically, you can think of fit as learn. This is when the machine learns, right? So it learns from the training data, right? It learns from the training data, some from the Y, right? Some from the target, right? The MPG, right? Some from the MPG, and then some from the all the other variables, right? Which is the acceleration, the cylinder, the other variables, right? So we learn from these variables that we are given. So this is when the machine learns, right? So we fit it, okay? Then after that, we can actually fetch the coefficient. So let me go down a bit. And then use, yeah, better. Okay, so we can actually use regression underscore model dot coef underscore. All right. So this one is just a parameter. Is a parameter in this linear regression, which is containing all the coefficients. If you remember the equation of the line is equal to m, and then y equals m, and then x plus a certain c, right? So now you can, as I said, it can be a hyperparameter. So it can be y equals m1x plus say m2 say z plus say m3 say q, right? Now what is these ones, right? What this x z q is representing is the same as maybe cylinder, maybe y equals say m1 cylinder, all right, plus say M2 displacement, all right, M2 displacement plus M3 something else horsepower plus M4 weight plus M5 acceleration plus M6 model plus M7 origin America plus M8 origin Asia, something like that. Okay, so that's what this. So this we have more than one independent variables, right? So these become a hyperparameter, right? All these are putting together to predict our MPG. So our Y here is our MPG, all right? So we are basing on all these cylinder, displacement, horsepower, all these characteristics, right? We are basing on that to predict the MPG. So that's what this was actually giving us. So we can actually form an equation with this, right? As maybe MPG. Over here, it cannot actually fit because this is too much here to fit just here, right? So we can just say MPG equals, and then our coefficient, right? Let me go down a bit so you can see the coefficient over there. Yeah, the intercept that we're talking about, like the C was the y-intercept, right? If you remember the equation, we draw the line and then it cuts somewhere at 1. Then we say that it was 1, y equals mx plus 1. So the 1 was the intercept, right? So we can also use this intercept function here to find the intercept. So whatever equation that we form, right? Whatever equation that we form, let's say M1, the first M1 is negative 0.39, right? So this is going to be negative 0.39, all right? And then cylinder, that's the name of it, right? Let me just shorten it like that. And then the next one is plus 0.29. I'm just running it off, right? That's the displacement. That's for the displacement, right? So displacement here. And then the next one is negative, all right? Negative, so it's going to be minus 0.21. And that one is for horsepower. So let me just represent it with HP. The next one is minus, so minus. So this is, we can continue to form this equation, all right? And then next time, if we have cylinder, if new data comes, right? And then we have cylinder input, right? Cylinder value. So let's say cylinder equals 1. And then we got displacement equals say 50. We got horsepower equals say 20. Now we can multiply these values with this coefficient that we are having and then predict the MPG. Okay, so this is what the model is about. So after that, this one is the equation that it has formed. Though it will not show the equation here, but we can actually write the equation down. All right, and then see that, okay, if we have new input, new cylinder values, new displacement values, new horsepower values, new model year, whatever values, right, so that we have here, we can actually predict our MPG. Okay, so this one will actually give us a rule, or it will give us an equation, so that next time when new values come in, we can actually predict. And that's what machine learning does. It actually sets a certain fundamental rule for us, which when new data comes in, it will just feed it into that. So now we don't need to actually do all these things that we did again. We only have this. So if there's a company that wants to always predict the miles per gallon of a certain car based on these attributes, right? You have this, so you do this and give this thing to the company. This is all the company is looking for. This equation is all the company is looking for, all right? And this is what we call the algorithm, right? This is what you have built, or the model, right? This is what the company will hire you to do. So you've built this. So now, if new data comes in, the company will just come and put it here, right? If they have new cylinder values, they have new displacement, they have new HP, the company will just feed it in here, all right? And then automatically we can predict this. So the company can use this over and over again, so that the company will not sit down to work it all over again, over and over again every time, right? You just do this, and then this is what the company is looking for. All right.
What exactly this in for loop enumerate function is doing?
Okay, you said what exactly is the for loop?
In for loop, there is a function called enumerate.
Yeah. Okay. I actually was expecting that, and there was another one up here which no one even asked. There was another function that I used up here somewhere. Okay, whatever it is. I was actually expecting someone to ask that question, and after that, if no one asks, I'll actually ask someone. So now, if you are building any algorithm, right? If you are building now, if you see this enumerate here, I put string dot columns. All right. There's different things that you can actually put in here, and there's some other what do you call it? Other arguments that you can even add, right, to make it more efficient, right? Now, what you can do is that when you are building any algorithm for any company, especially in machine learning, it's possible that you might not know everything, and you might not know a lot of stuff. So what you do is that if you see something like that, right? For instance, this enumerate, right? Maybe I'm not here to ask me. You just put it there, and then look for don't just pick any site and then go. Just look for the official site. Let me see if I can see this Python site. Okay, let me do it. Enumerate by done. Yeah, this is the official document, right? Then you go to the official document over there. Now, from here, right, you can find a lot of stuff out of it. Let me go down and see where I can find this enumerate. Yeah, you can see enumerate here, right? Now you can see what the enumerate is being used for, right? You can read about the enumerate and then see an example of what it's being used for, right? And you're going to do this over and over again, especially in this machine learning, I mean, this journey of machine learning. There are a lot of stuff that you need to do, you need to search, especially the official documentation. You need to read it over and over again and see how you are going to use. There are some arguments that if you even use, it will just mess up your algorithm, the final performance altogether. So before you even use it, make sure you read the official documentation. All right. So this one, I'm not going to read it to you, and I'm not going to say it. So when you get the code, just search for yourself. All right. Just go to the official page. Make sure it's the official documentation. All right. Then you read about it and see. And then just try to change this. Just try to change these dot columns here. All right. Just try to change this dot columns here and then see what happens to the final model that you will get over here. Okay. So when you get it, just do that one.
And
Um,
also in the train and test split where you use some random state equal to 1.
yeah,
Uh, so
yeah,
what does
that's
it
why I
mean?
said that the random state is, I mean, this number is just a number that you set by yourself. If I even use random state equals 2, it's actually not giving me any impact here. It's actually not giving me, let me just run this one and then you can see over here. All right. There are some of them you just need to just track it by yourself. Okay. It will just give me new random variables, but when anytime that I run it again, like I'm having negative 0.533 here. Now, if I just run it again, if I just run my algorithm again, you see that I still have negative 0.533 here. But if I don't set that, right, then if I run it again, maybe I'll build this algorithm, then I'll give it to my project manager or my supervisor, right? Then he will also start to run it and see, right? But if he runs it without my random state, he's also going to get a different values altogether. And then you'll be called back to come and explain, and then you do it again, and then it's giving you different results altogether anytime you run it. All right. So to avoid that, we set the random state, right, equals certain value so that anytime you run your Jupyter notebook or anytime you run your algorithm, it will still give you the same output. All right. Okay, so let me bring my pen. Let me bring my pen here and then let's run this one more time and see. Okay, with the pen I cannot actually, okay, let me get off the pen. Yeah. Okay, so let me just get off this. So now we don't have, if I go back here, we have the random state, right? So let me just delete this random state. I think we are almost done, so
Hello.
I can spend some time on that. Okay, so let me run
Hello.
it. If I run it again, now see, we were having negative 0.5422, right? Just watch that one, right? Just watch this one. Now I'm going to run it again. All right, so now you can see that we're having negative 0.489, right? We are having different random values, right? If I run it again, just see negative 0.48, right? I'm going to run it again. See now I'm having negative 3.4. It's giving me different random variables altogether. All right, but I don't want this. I don't want that. I want to get it the same over and over again. So that's what I would do. All right. Let me just show you this part finally before we we close this session. Okay. So now after building it, right? After building the algorithm, all right, after building the algorithm, so we've seen this part where we got the intercept of each of the attributes. Now, if you see this part, we are actually getting the score, right? We are getting the score, and we are getting the score on the training data. All right, you can see S train and then Y train. We are getting the training, the score on the training data. How well is our model performing? Now, our model is now stored in this regression underscore model, right? This is where our model is, right? This is where our machine has learned, right? In this variable called regression underscore model, right? So we want to see how it is performing on the training data, right? This is the data it has seen before. So when we did that and we get the score of that, we're seeing that our model is performing like around 81%, right? At 81% of the time, our model is correct. Right now, if we check it with the data that our model has not seen, which is the X text and then Y text, right? If we check it on that, we can see that it is performing at 84%, right? Which means our model is even doing better at the unseen data. Okay, our model is doing better on the unseen data. All right, and then now we can actually predict, right, on S text. S text is um, the variables that our data has not seen before, right? So let's say, if I uncomment this thing and show you, right? Now, if let's say the company is having new data like this, they came up with new data, right, of new variables. If you remember the equation that we built, we said that the company may have new cylinder features, new displacement, right? So let's say the company is having these new features. Now you built this algorithm for the company. Now the company, within about say 6 months or 3 months, the company got this data. Now they want to predict and then see how the miles per gallon will perform, right? Now they are going to feed this data, right? Going to use this data and then use your algorithm that you built for them, right? To see or predict the final output. So that's what we are going to do here, all right? So let me go down here. Now we are going to use the predict function to predict the miles per gallon, right? So if you run that, you can see that we're having like 20.94. So based on the first input, right? If we start putting 6 for cylinder, 171 for displacement, horsepower to be 97, all the way to origination here. If we put all this into our algorithm, right, we will predict the first MPG to be 20.9. Okay, we predict our MPG to be 20.9. If you see our MPG here, some are 25, some are 21, some are 40. So this, we are predicting same values, right? These ones are based on, so if you see 25 here, it's based on cylinders which are being for displacement 98, some weights 2046, acceleration, all the way to this, right? So all these data points are used to predict this 25, right? So with all these attributes, we can see that the MPG will be 25. The same here. The same here is the same thing is happening here, right? With all these attributes, we can predict the first MPG to be 20, the second MPG to be 27.78, the third MPG to be. So this is after building your algorithm, this is what the company needs. They just need this single thing here, all right, so that they can put in new data sets and then predict their final output. Okay, so this is a linear regression. Okay, so with this graph is just like the more percentage that you get, all right, like if the percentage is small, right, so like this one is more like 15%, right, and then this one is like 84% that we got. The higher the percentage or accuracy that you get, the more closer your points are to the regression line, right? Remember that we are saying that the distance between each point and the regression line is an error, right? And you want to minimize this error as much as possible. So you want the point to be closer to the regression line as much as possible. So depending on the accuracy that you get, right? So the higher the accuracy, the more accurate your model is, all right? And we will also talk about something else later on in the course, that if you get an accuracy like this, how you're going to report this. Because you cannot tell the company that your model is performing at 84%, right? Normally you give a range, maybe 84 to say 90 or something like that. Or maybe you give it lesser, maybe 75. So maybe within this 75% to 84. So you can say to the company that at 75 to 84%, my model will predict correct, right? Or maybe at 84 to 90%, my model will predict correctly, right? We will talk about that one too. Okay. So is there any question? Is there oh,
What about cross validation? How my model is working?
yeah, cross validation will come later. It will come later in the course. I mean, we are taking it step by step. I know how fast you want to know that, but we will do that, right? Cross validation will come later on in
Okay.
the course.
Okay.
Yeah, there's model validation back. I mean, in the syllabus, so we do model validation, and then we talk about cross validation. It's not only cross validation. There are some other concepts too that you can use to validate your model. Okay. Any other question that's anyone is having any?
Hello.
Yes. Hello.
Could you please go back to that training and testing splitting dataset code about?
Mm, yeah.
Yes.
But
Is this the standard format to write this code? Means I could not understand that what is happening right now here. X train
it's
and X test. These names I can define by my own. Or
okay. Like let me bring my pen. Like I use X train and then Y. I mean H test, then Y train, Y test, right? That's what you mean.
yes, yes.
Okay. So you can call this one as M if you want. You can call this one as N. You can call this one as O. You can call this one as say um um I just want to use any name. You
Okay.
can call it
But
an AP,
but
whatever you want to call it. But
what exactly is happening here? Means
yeah,
mm,
the thing, what you want to know, right? What you want to know is that you use a name that is reasonable to not only you, but to anyone that picks your code. Now, what it's saying is that we are going to split this data set, right, which was around 300 and something. Let's just use 350, right? We're going to split this data into 70, 30, right? Now, what is happening here is that we have some data which are stored in X, we have some which are stored in Y, right? And then we group some into training and then some into testing, right? Some into training and then some into testing. Now, when you pick the X data points, right? The ones, who is showing me his face? The ones that are in training, right? Which is this data point, right? We divide it into two, which some are going to be used to train, and then some are going to be used to test. So that's why you see X underscore train. So some of the values in X are going to be used to train. Some of the values in X are going to be used to test, right? That's why you see X train, X test. And some of the values in Y are going to be used to train, some are going to be used to test. So when we split it, right, the ones that are in X that are going to be used to train, store it in X train. Okay, the ones that are in X and are going to be used to test, store them in X test. And then the ones that are in Y that are going to be used, let me bring this. The ones that are in Y that are going to be used, right? So Y here will be divided into two, right? This Y will be divided into two. Some will be used for testing, some will be used for training, some will also be used for testing, right? So if you, the ones that will be used for training, store it in Y underscore training. That's why you see this one here. And the one that will be used for testing, right? Store it in one Y underscore testing. That's what's happening here. Okay. So each of these, right, this data point, this X here, right, is containing a lot of data points here, apart from the MPG and the origin, right? It's containing those data points. So it will be divided into two. Some will be used for testing, some will be used for training. And the ones that
so
will be used for
so
testing,
where here test size is equal to 0.30 means 70 is to 30. Means 70% for training data set and 30% for testing, right?
Yeah, for 70 for training, 30 for testing.
Okay.
Yeah.
And what did you told about that random state one? Means it is a seeding point.
Okay.
Means to
Let me minimize this. Just give me 1 minute. Okay. So the random state, right? What's someone's microphone is on and it's I don't know. Okay, let me mute this. Yeah, good. So the random state, right? For the random state, what we are saying is that when we run the algorithm, right? When we are building the algorithm for the company, okay? And we don't want to be generating random variables over and over again, right? This 70-30, right, is generated randomly, okay? Oh my. This 70-30, right? Yeah, thank you for offing the video. Please turn off your video for me, Ashok. Yeah, if you can turn off your video for me, I'll be glad. Okay, so this 70-30, right? This 70-30 that we have, this 70 is selected randomly. This 30 is selected randomly, okay? So if we run the algorithm, the number of times that we run, it will generate new random variables for us. So as we run this one, let me get this thing off. Okay, now if you see here, right, we are setting random state equals 1. It means that anytime I run this algorithm, select the same random variables that you selected at the first time I run it. You get it. The first time that you run the algorithm, the random numbers that it will select, you want that to build the algorithm. You don't want to generate random numbers over and over again, right? When I close this Jupyter notebook, then I come back tomorrow and then run it again. I want to see the same random numbers. I don't want to generate different random numbers. That's why I'm just setting a seed. Normally we call it a seed, right? That's why I'm setting this random state equals 1, so that I'll be getting the same random numbers over and over again. Okay. Otherwise, if I don't set anything here, right? If I don't set anything here, and then I run this, right? Now you can see it over here. Now I fit my model. Then I show you the coefficients, right? Now I'm getting negative 0.287, blah, 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 and some other random numbers here. Now, if I run this algorithm again, right? If I run this again, it's going to select different random numbers. It's going to divide the data into 70-30 again, with different random numbers going to 30, different random numbers going to 70. Okay. Now, if I run it again, now if we see the coefficient, right, we will not get negative 0.287 again. If I run it again, now you see we are getting negative 0.2354, right? It's different, okay? But I want it to be the same anytime I run this Jupyter notebook, all right? That's why we set this random state. Okay, any other question? Okay, so if I think today we've extended the time like seriously. So if there's no other question, we can close here. All right. Thanks everybody. If there's no other question, we can close it, and then let me off this recording.